All right, guys, I'm gonna quickly go through this to make sure you understand the homework for day 6 or the classwork day 6. We went over, most of it together, but I just want to make sure we are, you understand what this graph is talking about, okay? So the first thing is for each graph A, describe the end behavior, right? That's what we're doing, end behavior for A. So I'll just write end behavior, right? And determine whether if the graph is an even or odd, right? And then say determine the signs on the leading coefficient. Is it positive or negative, right? Positive or negative is what we have to do. So looking at just this graph, remember when I was talking to you about the graph, like especially with this two, but let's start with the first one, which is end behavior. So we look at as x approach, oh, what did I think? All right, as x approaches positive infinity and x approaches negative infinity, right? Those are the two graphs we have. As x approach positive infinity, meaning as x goes this way, the graph is going up, right? So f of x, the graph is going to positive infinity. When x approach negative infinity, so when it's going to the left side, the graph is going down, right? The graph is going down. So f of x would be approaching negative infinity. That's what we have to do. Okay? So as x approach positive infinity, it's positive infinity because it's going up, 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 up. If it is negative, it's going down, so it's left. Is it an even or odd? You just have to look at the term, right? 1, 2, 3, 4. So if it is 4, it's always the terms is the term plus 1 is even odd. So 4 plus 1 is 5. So it's going to be an odd function. Okay? And is this positive or negative? Since when it goes to the positive direction, it's going up. When it's going to the negative direction, it's going down. This is a positive graph. Okay? So the same thing, we can do that number 2. So you have to do one, what happened as x approaches positive infinity, as x approaches negative infinity, what would be the f of x would be, right? So when x is going to positive direction, the graph is keep on going down, right? So this is going to be negative infinity. As x approach negative infinity, the graph is still going down. So f of x is also negative. They're both going to negative direction. Negative infinity. Is it even or odd? You just count the terms. 1, 2, 3. 3 plus 1 is 4, so it's going to be even. You always add 1 to find if it's an even or negative. This is clearly a negative graph, right? Both going down. Okay, so now number 3 and 4 is asking you describe the end behavior of 14th degree polynomial with a positive leading coefficient. So it tells you here, it's 14th degree polynomial, right? And it's going to be, the leading coefficient is going to be positive. Okay, so, and they're asking you for the end behavior, right? So what happened as x approaches negative infinity, the graph is going to be going positive infinity. As x approaches, well, I think I should write it this way, so that you're not getting confused, sorry. As x approaches positive infinity, its f of x is going to be positive infinity. Okay, because it will be going up, like whatever turns it's gonna make, it's all gonna be something like this. It's gonna make more turns, but it's gonna look like this. Okay, all right. So number 4, this is describe the end behavior when it is 9, which is an odd, and then it's a negative leading coefficient. Okay, so it's kind of gonna be opposite, right? As x approaches positive infinity and as x approaches negative infinity. When it's approaching positive infinity, since it's down, f of x is going to be down, negative infinity. As it goes to the left, it's going to go to the positive. Okay? And then now for number 5, we have to do graph each function given its key characteristics. Use the graphing calculator or the turning point and the round to the nearest degree. So all we have to do is just graph this part, right? And then we're going to decide if it's domain or range. So how do we graph it? We use Desmos. Okay, so I'm going to open that. All right, so I just graphed this negative x cubed plus 6x squared minus 10x plus 4. And then now, based on this graph, we're going to write the domain, the range, and what is the real maxima, what's the real minima and behavior, right? So domain, as I go this, the graph is up, going this way. So domain and range in this case will be all real numbers, because range also doesn't have any limitation, right? So it's going to be all real numbers. So what is the real maxima is the question, right? What is the real maxima? So you have to look at it where it's becoming the highest point. So the highest point is going to be right here, right? The turns, and then the minimum would be this one. Okay, the highest point is 2.816 and then 1.089, and the minimum is 1.84, right, comma negative 1.089. What happened as x approaches negative infinity? As you go this way, it goes a positive infinity, I'm sorry, it's going down, right? If it's approaching negative infinity, it's going up. All right, what is my increasing interval? This is the tricky part, right? So it's going down, 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 up, down. Okay, so the increasing interval is only here. Everywhere else is going down. So I'm going to put, oh, and then when you write this, you only write the x coordinate. 1.18, comma 2.82. And then the decreasing interval is negative infinity to 1.18. That's one. And then the other one will be 2.82 and positive infinity. Okay? Alrighty, we're going recording. So the first thing I want you guys to do, this is number 5. I don't know if you guys could, or 6, right? No, 6, yeah, 6. So go ahead and let's put this in Desmos, right? We come here. Everybody open up your Desmos and do it this way. 2x to the power of 3 minus 7x to the power of 2 plus 6. Okay, so everybody got, and if you want it, you can kind of graph it here, like if you want to, but you don't need to. But the big thing is to graph, you gotta, those are your key points, right? 0, 6, 1, 2, 1, 2, 3, 4, 5, 6 is here, I believe. 1, 2, 3, 4, 5, no, one more. 6 is there. So that's one of my turning points, right? And then my intercept here is negative 8.3 and 0. So it's not quite 1, but somewhere right there. And then this one is 1.124. It's a little bit here. And the reason I like Desmos is because you can make it bigger, right? Like this one is going to be really close to each other at 3.29 and 0. So this is 1, 2, 3, somewhere right here, right? So my line, this is just free drawing, right? It's going to go up. Then it reached that maximum. It goes down. What is this maximum? 2 point and negative 6 point something, and then it's gonna go up, right? So this kind of helps me to see my increasing and decreasing interval when you're kind of looking at it, right? So now, what do you think is the domain? So now you guys have to help me. What do you think is the domain for this graph? When you look into your x-axis this way, do that graph intersect the x-axis everywhere? Like, do I have a location? What do you think is the domain? Come on, guys, what's the domain? I'm waiting. Adley, Connor, Giovanni, Ishmael, Jacqueline. Domain is what? All real numbers, because it goes up infinite this way, down this way, so the x is covered. The same way for the y, it's going to be all real numbers, because it keeps going, right? There's no limit. It keeps going. So that's going to be all real numbers. So what is the relative maximum? What's the highest turning point do we have? So this you can do, right? So you guys have to chat it, even if I'm pointing it at. So what is my maximum, relative maxima for here? Zero and 6. Thank you, Giovanni. 0, 6. Awesome. What is the relative minimum? The minimum is right here, which is, you should graph it and have this on your thing, so you shouldn't be trying to squint your eyes trying to look at this. This is what? Good job. Thank you. 2.33, right? 2.33, comma, negative 6.7. Let's just do it to the nearest hundreds. Okay, so now this should be easy. And behavior, as x approach positive infinity, as you go to the positive direction, where's the graph at? Is it in the positive direction or is it in the negative direction as you go to the right? Go ahead, Connor. I can't hear you. Did you guys hear him? I saw his mic. What he did? Can you can hear him? Yes. Oh, okay. What? So can you tell me or chat it what he said? He said positive. Thank you. I don't know. Like maybe I probably have to log off, but I'm not gonna log off. Let's just keep it um with the chat, okay? Because it's just since I think I had the other Blackboard open, so when I close it after I open this, I think my audio is still in that one. So, but you can hear me fine, right? Yes, okay. All right, so what happened as x approaches negative infinity? When I go to this direction, what is going on with the graph? Is it going up or down? Negative. Awesome. So it's approaching negative infinity. Okay. So this is the interval, increasing and decreasing. That's why I like to draw it, because it kind of helps you to understand what we're doing. So when we are going up, let's use the green pen, right? So for this graph, like you can see it from here too, I'm going up, 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 up to here. Then red is going down, and then from here I'm going up, right? So the increasing interval is my green. So when I write it down, it's from negative infinity to that maximum point, which is 0, right? When x was 0 is that maximum point. So went up until x reaches 0, and then it went down with this interval between 0, and then let's do the green. It went up again from here all the way up, right? So what is the x coordinate of this one? Gotta look at the 2.33 to positive infinity. It just keeps going up, 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 right? And then the negative one, when the decreasing is this. So who can give me the decreasing interval from here to here? So what is the x coordinate here? What's the x coordinate here? That's all you have to say. So it's decreasing in which interval of x? All right, come on, guys. It's between this to here. What is this? 0, awesome. From 0, comma, the x, only the x. I don't need the negative 6.7, Connor. 2.33, yeah. Awesome. That's it. 2.33. Okay, that's what you have to do. All right, let's do the second one. And I'm gonna, what I will do is I will pause after we graph it, and then you'll do this, and then you'll tell me, okay? So now everybody go ahead into your Desmos and graph this. So we're gonna put x to the power of 4. All right, I don't need a keyboard. Okay, x to the power of 4, right? Does it have? So you just have to go back the square and just make it 4 minus 4x cubed, 4x cubed, cubed, plus 3x squared, 3x squared, plus 4x minus 5. So that's what we have, right? So I mean, if it makes it easier for you guys to graph it on your paper, you can graph it. But even if you don't graph it, you can see this and try to do this part. So it's like something like this, right? You go down, you reach a point right here, and then you kind of go up, then you go down and up again. So let me change the up color into green. So it went up here, from here to here, it went up. Then it went up from here to here. What's the distractions kind of hard. All right, so the rest is down, down, up, down, up. So when you get to here is where you have to be very careful. So I'll pause this for maybe 3 minutes for you guys to do it, and then we'll go over it together. Me So for number domain, what is the domain, guys? All real numbers. Awesome. The domain is all real numbers. Range. Range has limitation, right? Oh, no, no, no. See, the range starts here and goes up. There's nothing down here. So it starts from here, but it goes to the positive infinity. Yeah. So range, the starting point would be negative 5.8, right? Negative 5 point, the y. So range would be, well, I guess we have to do it close. Negative 5.848 to 8, this is 8, to positive infinity, right? Because it starts from there and then it keeps going up. So yeah, it has limitation. If this had went down this way, for example, then it would be all real number, but it didn't, right? So it just both is going up. Okay. All right. So what is the relative maximum? Just the only one I see is this, right? That's where it humps, right? Am I correct, Mr. K? 1.36, comma, negative 0.69. 65, I'm sorry. I don't know if anybody's talking. I can't hear anybody, so you guys have to use the chat. All right, and yeah, Mr. K, they probably can hear you, but I can't hear you. Okay. All right, so okay, so you gotta use the chat. I know you can hear him. I can't hear anyone if you. I have to log off and come back in order to hear, and I don't want to do that because I'm recording this. Oh, I can maybe pause it and do that. All right, let's finish this and, well, let's pause it then, I guess. What happened when x approached positive infinity? Positive, awesome. And what happened when it is going to the negative infinity? When I go this way? Awesome. Yes, also positive. Yep, it's also positive. Okay. So now let's do the interval of increasing and decreasing. So red is going down, up, down, up, right? So we go down, up, down, up, right? So the interval for increasing is from here to here. So from negative, what is it? It's negative 0, negative. Hold on, sorry. Okay. Negative 0.36. Okay, comma, the up to 1.36, right? Okay, that is one increasing, right, from here to here. And then it starts increasing again from here to here. So from positive 2 to positive infinity. I don't have space, so I'll just do that. And then the decreasing one, I will use the red color. So for the decreasing interval, it went down from negative infinity all the way to this point. So decreasing is from negative infinity to negative 0.36. And then it went down between these two intervals right here, right? From 1.3 to 2. 1.3, comma 2. Okay? I hope you guys can do the last one all by yourself. All right, and I would. I'm not gonna go to the next one. Maybe I'll just put it on Desmos so that you guys can see. But while you're doing copying that, I wanted to take attendance.